Okay, dear. So let us start now. We are going to have a discussion over the natural vibration. It is natural vibration 2. And when we are having a discussion over natural vibrations 2, I would like to say that whenever we are having a natural vibration 2 part 1 is over yesterday. And yesterday we were having a discussion over energy method. And my dear, energy method are having basically two major applications. One, if we are going to have pure rolling motion. If you are having pure rolling motion, energy method is going to be very helpful. I am telling you how. My dear, this is a spring. This is attached with a cylindrical disc. Attached with a cylindrical disc. So it is having a mass of m and radius of s and stiffness of k. If stiffness can be shown by s also, it can be shown by k also. So my dear, this is fixed. It is going to be fixed. Sorry dear, I'm basically, as this lecture was on YouTube but it was not coming on YouTube, that's why I'm just giving a message to that, so that those students can also join us on app only. Okay guys, so this is the stiffness and this is mass and radius of the disc. And when we are having the pure rolling motion, my dear, you already know that pure rolling motion is a combination of pure translation as well as pure rotation. So you know that if the system is having, when you're talking about pure rolling motion, as it is always mentioned that this cylindrical disc is having the pure rolling motion only, then what we are going to do that pure rolling motion is a combination of pure translation and pure rotation. The pure translation part is having a kinetic energy of half mv square. And you know that pure rotation, the kinetic energy is given as half I omega square. But you know, I for cylindrical disc can be written as mr square by 2. So it can be written as half into mr square by 2 omega square. It means 1 by 4 mr square omega square. R omega is V only, so it is 1 by 4 mv square. So my dear, if you're going to have the total kinetic energy of the system, it will be half mv square plus 1 by 4 mv square. It will become 3 by 4 mv square. So I told you, my dear, if this kind of question is given, a spring with stiffness K and a cylindrical disc with mass m and radius r are given to us. Mitesh, hello. Mitesh Jadhav, hello. So dear, as I told you that pure rolling is a combination of pure translation and pure rotation. The kinetic energy of pure translation is half mv square and that of pure rotation is half I omega square. And when we are talking about hello Siva Kumar, hello Jay Kumar, if we are going to have total kinetic energy to be 3 by 4 mv square, you know that the total potential energy of the system is half kx square. So if you want to have total energy, you just need to add that. So energy method we are going with. You will be saying total energy of the system is 3 by 4 mv square plus half kx square is equals to 0. You know that this is total energy and energy differentiation with respect to time is 0 because energy of the system is constant. So V can be written as x dot. So you can write it as 3 by 4 mx dot square plus half kx square is 0. Sorry, is constant. This is not 0, this is constant. And if you are going to write dE by dt that is equals to 0, you will be getting 3 by 4 m into 2x dot into x double dot. Just wait guys, I just got a call from technical team only. Hello. Hello. हेलो हाँ सर सर ऐप पे हुई है यूट्यूब पे एरर दिखा रहा है नहीं ऐप पे चल रही है सर इसीलिए तो मैं कॉल इसलिए मैंने अमन को भी कॉल किया आपको भी मैं मतलब स्लैक पे कर रहा था कॉल मेरे को खुद को यही लग रहा था कि ये मतलब ये तो मतलब मल्टी है तो दोनों में चलनी चाहिए ऐप पे चल रही है यूट्यूब पे नहीं चल रही यूट्यूब पे एरर दिखा रहा है और इसलिए मैंने यूट्यूब पे मैसेज कर दिया कि प्लीज ज्वाइन ऑन ऐप आप देख सकते हो पता नहीं सर देख लो आप आपको स्क्रीनशॉट भेज देता हूँ देख लो चल रही है क्लास मैंने अभी वीडियो कैप्चर ऑफ किया हुआ हाँ ठीक sorry guys for disturbance actually the problem is as I told you the class was on YouTube but it is going on app so there is some technical error but don't worry let us continue what is with us you are going to learn something new so it is 3 by 4 m 2x dot into x double dot plus half into k into 2x into x dot it is going to be equals to 0 my dear so 2 will get cancel out x dot will get cancel out you will be getting finally 3 by 2 m x double dot plus kx is equals to 0 and x double dot plus 2k by 3m into x is equals to 0 and my dear this is the governing equation and you know by comparing it with the governing equation of SHM natural frequency of vibration will come out to be equals to square root of 2k by 3m. Guys, are you getting it or not? Whatever I am telling you, are you getting it? This is the natural frequency of vibration for this case. And I would like to tell you that whatever we have taken the I for this disk, this is about this axis which is going inside ZZ axis. So IZZ is mr square for which r is the radius. So mr square by 2. Now my dear with this question you can make many questions. In GATE this was asked as a cylindrical disk but sometime they may ask it there are many options they may ask it as a cylindrical disk as we have just discussed or I must write it in this way that they can ask it as a ring for ring I is mr square ring or hollow cylinder they are same thing they may ask it for solid cylinder or disk I will be mr square by 2 nice Shiva Kumar Nishant Jay Arnab and all and here if they are giving you hollow sphere or solid sphere it is going to be 2 by 5 mr square or 2 by 3 mr square. So by just changing the geometry they can change the answer. Case number 1 is over. My dear, second application of this energy method is if spring is not massless. If spring is not massless, up to now we were saying that spring is storing some potential energy. Mass is storing some kinetic energy. But if spring is also having some mass, then it will also be storing some kinetic energy. So this time the total energy of the system will consist of potential energy of spring, kinetic energy of mass, kinetic energy of mass of spring. Okay guys. So this is the way how we can proceed now. So let us consider, we need to find out the kinetic energy of mass, kinetic energy of spring, because these two things we all automatically know that. So let us find out the kinetic energy of the spring. Let us say this is a spring. And you know that in general we write kinetic energy to be half mv square. But you know that if I am considering this spring, the velocity of spring, if you will be finding out, for this end the velocity is 0. For this end the velocity is equals to x dot. S is stiffness of spring. Okay guys. So if V is equals to x dot, this V is 0. So it means V is changing from this to this. So we will be considering a small part of this spring. And when we are going to consider this small part at a distance of y with the length of dy. So for this part, if ms is the mass of L length, if L length of spring is having a mass of ms, 1 meter length will be having a mass of ms by L, and dy length will be having a mass of ms by L into dy. This is small mass of the spring. Okay, so this small mass is ms by L into dy. Nice, Sumit. So if this is going to be the mass and we are going to see velocity, you can see that if L is the length of the spring, in L length the change of velocity is going to be x dot. From 0 to x dot it is changing now. For 1 meter it is going to be x dot by L. And for a y distance it is going to change by x dot y by L. It is Vy by L. This is the change of velocity. Initial velocity is 0, so this is going to be the final velocity also. It is going to be x dot y by L. Okay guys, it can be written as V by L into y. So now if we are going to write that kinetic energy of the spring is half chota sa mass velocity square, velocity of spring square, we will be writing half chota sa mass is ms by L into y, V by L into y का square. This is kinetic energy of spring. So it is given as half ms by L into y v square L square into y square. Okay guys, this is ms by L into dy. You know that. So this is the small kinetic energy of a part of spring. Now this is not total. This is a part of spring. Kinetic energy of a part of spring. For total, we need to integrate it. You need to go for integration. So it will be integration of half ms by L cube v square y square dy. Integration from 0 to L. Y square dy will be y cube by 3. So 1 by 6 ms L cube into v square into L cube. So L cube will get cancelled out. It is 1 by 6 ms x dot ka square. So this is, my dear, kinetic energy of spring. We are going to have it. If you are going to find out the total energy, it will be potential energy of spring kinetic energy of spring, kinetic energy of mass. So it will be half sx square, half it is ms, not half, 1 by 6 v square, half mv square. V means x dot. So this is total energy, and you know dE by dt is 0. Energy of a system is constant. So we are going to use energy conservation of system, not of universe. So you'll be having half into s into 2x into x dot plus half into m into 2x dot into x double dot. So dear, it is going to be equals to 0. You know that x dot is common everywhere. 2 will cancel out 2, 2 will cancel out 6, and 2 will cancel out 2. You will be getting so m plus ms by 3 x double dot plus sx is equals to 0. It will become x double dot plus so omega n will be natural frequency of vibration of that system. Okay guys, thanks Jay. So these are two applications of energy method where you need to use this for sure. Now after energy method, we are coming with torque method. When we say torque method, it is not at all a new method. It is nothing but, I will say, it is D'Alembert's principle for angular vibration. Sunny Sahu. So dear, don't ask this kind of question. Okay. You can ask me this kind of question only at personal platform, not on this. Okay. So don't worry about that. This is a simple pendulum. I am going to take it. Mass M, length L. And my dear, you know that for vibration, initial disturbance is required. Let us give an angle theta. Rotate it by an angle of theta. This is initial disturbance. And you know what we have done here? M is acting in downward direction. This is mg. And this angle is theta as we have rotated it by theta. So mg will be having two components. Mg cos theta, mg sin theta. So guys, you know that this kind of force is known as restoring force, which wants that body to again come to the original position. It is said to be a restoring force. But my dear, as we are going to discuss the angular motion here, rotation motion here. So in rotation, forces are replaced by torques. So I will be taking the restoring moment rather than force, and that will be force into this perpendicular distance. You will be writing it mgl sin theta. This is restoring torque. And D. Lambert said that add my component into this restoring torque, equate it to 0 and get my equation. So the equation which we are going to get is going to be I theta double dot plus mgl into theta is equals to 0. From here you can write down theta double dot plus mgl. Basically it is mgl sin theta only, but the disturbances we provide is very less. So sin theta can be written as theta only. Because when theta is small, sin theta become theta. It is mgl by I into theta. Mitesh Yadav, please refresh your system because it is not buffered from here. Omega n will be mgl divided by I. And for this mass which is having an angular motion about zz axis, the axis passing through the plane of paper from this point. So you know that it is at L distance apart, so I is going to be ml square, mgl by ml square. It is square root of g by L. So guys, Fn can be written as 1 by 2 pi. This is something known as, my dear, that torque method. This is, we can say, yes dear, theta double dot is acting like alpha only. As you know, F is equals to m into A, T is equals to I into alpha. Yes, Vicky, you are very much correct. So guys, this was torque method. I am going to give you the application of torque method. Torque method is applicable if pure rotation is present. Pure rotation is present. How pure rotation will be present? Let us say this is the body and you are having, this is fixed about this point. A spring is attached with S1 stiffness, with S2 stiffness. And here the radius of this is R. And this is a disc. So I for this is mr square by 2. So dear, let us see how to find out the natural frequency of vibration for this case. Just give a small displacement theta to this. So when it will be rotated by theta, spring will be displaced by x. X is going to be r into theta. So when spring will be extended, it will be applying a restoring force equals to S1 into x. And you know that the restoring force is S1 into x, the restoring torque will be, because you have rotated by theta, so restoring torque will be S1 into x into r. Similarly guys, as it is rotated by this, definitely this S2 spring is also going to be extended like this. This is something, again x is equals to r into theta. So again there will be a restoring force, that is S2 into x, and a restoring torque is again there, S2x into r. So dear, how you will be writing the equation as I theta double dot. Add the D'Alembert component into restoring torque. What is restoring torque? S1 r square theta plus S2 r square theta. It is equals to 0. And theta double dot can be written as S1 plus S2 r square by I, theta is equals to 0. I for disk is mr square by 2. Putting that, you will be having theta double dot plus 2s1 plus s2 divided by m omega, and you will be getting guys square root of is it okay guys? So this is natural frequency of vibration, a wonderful one. So guys, do you want to solve such a question? If I give you, will you be able to solve? Then the question is, we are having this stiffness S1, S2, S3. Dear, because both are creating the torque in the same direction. You can see both are creating the torque in the same direction. Yes, they are in opposite direction. One is in this direction, another is in this direction. But they are creating the torque in the same direction. Okay then. Then don't solve this question. I am going to move one step further. I am going to discuss some good question now. Leave this. This is easy one. So dear, the question is now, this is a disc, and this disc is attached with a spring at this point, stiffness S1, another spring of stiffness S2. This is center. This distance is D, and the radius of this is A. Shiva Kumar, did you get what I taught in the previous case? So now I am asking the natural frequency of this system. My dear, here you are having two choices, as it is a pure rolling motion. So due to pure rolling motion, you can use energy method. But at the same time, every pure rolling motion can be considered to be a pure rotation about the point of contact, because this is the I center of rotation in pure rolling. For pure rolling case, I center of rotation is the point of contact. So this disc can be assumed to have pure rotation motion about that point A. And if you are going to assume this to have pure rotation at point A, then my dear, we will be finding out this by considering pure rotation by torque method. Okay guys, so by this method, this A point is acting as I center, and the distance from this point is A plus D. Okay dear, so it will be acting as a radius. If we have rotated this by theta, and if at point A is acting like a instantaneous center, and about A the motion of the disk is pure rotation. So when I will be saying that this is going to rotate by theta, the distance traveled by this point is going to be A plus D into theta. And if it is that this spring is expanded by A plus D into theta, and this spring is compressed by A plus D into theta, so there will be some restoring forces. There will be some restoring forces here and on this also. This will be the restoring force with S1 A plus D into theta, and this will be S2 into A plus D into theta. So if you are going to multiply the distance with this force, it will result into torque. So restoring torque 1 is S1 into A plus D ka square into theta. Restoring torque 2 is S2 into A plus D into theta. So I theta double dot plus S into A plus D ka square into theta, S1 plus S2 A plus D ka square into theta is equals to 0. Theta double dot plus S1 A plus D square plus S2 divided by I. I, you know, for a disk is mr square, and theta is common. Okay guys, are you getting it? So this type of questions are being asked for 5 marks. In GATE, there was a time when GATE was asking 5 marks conventional question sometime. Nice guys. So this is a question which is a good one, and such kind of question may come into the paper. Okay, now I am expecting a question somehow simpler than that from you. What I have discussed was GATE 1995. Okay, sorry. Actually, we have done a mistake. I would like to tell you that. Sorry, guys. We have done a mistake. I is not mr square by 2. Yes, nice, dear. As I was mr square by 2, I told you about the point which is the center of the disk. About this point, O, it was mr square by 2. But if we are going to find out about A, it is going to be mr square by 2, apply parallel axis theorem, plus mr square, because r is the distance, because this is the center of rotation A na. So I need to find out about A. It will be 3 by 2 mr square. Very nice, dear Arnab. Good. So this is going to be omega n as square root of s1a plus d square plus s2a plus d square divided by 3 by 2 mr square. Nice, dear. Good, Arnab. And Nishant also. So dear, now I am going to give you a question. Okay, this is radius r, this is distance a, stiffness k. Find out natural frequency of vibration. And here these are simple questions. The best questions are when fluid mechanics and vibrations are combined. But I feel today there is not much time to say that. Nice. So the best question of vibrations are when we include fluid mechanics into it. That I will be showing you in the classes, because today I don't feel it is, the time is more today. Time is very less. So Vicky has given the answer root 2 Ka by 3m. This is the answer given by Vicky. Arnab, Nishant, I am waiting for your answers too. So you know that once again it can be assumed to be pure rotation about I center, which is point A. Once again IAA is going to be 3 by 2 mr square. Okay, Arnav is giving the answer r plus A upon r, 2k by 3m. Let us see, guys. So this is I, and if we are going to say that if we are going to rotate it by theta, this point will move by a point, move by a distance r plus A into theta about this center. So the force will be k into x, and the torque will be k into x into r plus A. This will be restoring torque. So I theta double dot plus k into x is r plus A into theta into r plus A is equals to 0. And guys, you can write it theta double dot plus k into r plus A ka square divided by I into theta बराबर 0. Omega n will be k into r plus a का square divided by 3m r square by 2. Okay, you are giving this as answer. Nice. Yes, Arnab, I got it. Nice, good answer. Nice, guys. Very nice. So, dear, now I am going to give you one more case. If we are having this as a rod of mass m and length L, and we are going to find out the natural frequency of vibration for this system, if it is hinged at a point which is at a distance of L by 2 and L by 2 from both top and bottom. If I say find out the natural frequency of vibration, this is your homework question. You need to find out what is natural frequency of vibration. And then if you say vibrations are there, you need to answer omega n. If somebody of you say there is no vibration, then there must be equilibrium. I am asking which kind of equilibrium. It is stable equilibrium, unstable equilibrium, or neutral equilibrium. This is a question, homework question for you guys. And with that, I'm going to conclude the class. But with that, I would like to say one more thing to you guys. There is an important announcement for you guys. From Friday, means tomorrow onwards, Gradeup is going to start a special series for you guys, which will consist of the previous year's question from GATE. And yes, as you know that IIT Bombay is going to organize the GATE this time. Organize, I am saying. I am not saying making the paper. It is going to organize, and because of that, all those years questions where IIT Bombay has organized the GATE exam, they will be covered as a special series on YouTube for you guys. You can attend from tomorrow. The time will be from 9 p.m. to 10 p.m. 1 hour will be there. It will be done for all the subjects. So there are 4 times when IIT Bombay conducted GATE. So all those times, whatever the GATE questions were asked in paper, they will be discussed in that special series for you guys. Hope you're going to get this. Otherwise, as I told you, this is just an organization. GATE exam is just organized by IIT Bombay. But yes, you will be learning some new questions, some new things into that. So you're going to have sessions related to that. So goodbye for this session, guys, and thanks for attending. And if you have any kind of doubt, I already have given my email ID to you. You can mail me. You can join me on Facebook. I don't have any official page till now. I'll be making that. But till now, you can use this email ID to share your doubts. And also you can follow me on Facebook directly by my name Dheeraj Sardana. Okay, Arnab. So goodbye for this session, guys. Let's meet. Goodbye.